Hello, I'd like to welcome you to my presentation today. I know that things are a little different this year with being a virtual conference, but I really hope that this presentation will help you in some way as we look at the projects that we did at Murray State University, and hopefully some ways that you can use this and take this along to university. So my name is Jake Hildebrandt. I am an associate professor at Murray State University in the Electromechanical Engineering Technology program. And today we're going to be looking at expanding applied engineering laboratories with limited funds while contextualizing industrial applications. I know that's a mouthful, but this is just a great project that we did at Murray State, and I'm excited to share this with you. So here's some of the objectives that we're going to be going over today with this presentation is we're going to be identifying some barriers that applied engineering programs have with expanding laboratories. I'm going to introduce you to the project that we did at Murray State University and show you some pictures and hopefully you get a good feel of our lab setups and some of the things that we're doing at Murray State. We're going to characterize some of the industrial applications that we contextualized while making these trainers that we're going to be talking about for this presentation. I'll review some of the outcomes of the project, and then we're going to explore some best practices and ways that hopefully you can take this home to your university and hopefully help you out in some ways. I want to tell you just a little bit of background about not only the project, but kind of our university, so you can have a better understanding of where I'm coming from. Murray State University is a regionally comprehensive university in rural western Kentucky. So if you look at Kentucky and the far western region, if you see the crook at the very bottom, that borders Tennessee, well, that's where Murray State is located. It's a very rural area. We are not close to an interstate. We are in Little Murray, Kentucky. So basically, whenever school is in session, we almost not quite double the population of Murray, but it's close to it. I think Murray has about 17 or 18,000 residents, and so whenever school's in session, there's a big difference than when it's not. We have about 10,000, again, enrollment at the university. We just created a new school of engineering at the university, and so this is exciting for us because we're actually expanding some of our engineering opportunities at the university. And so our engineering programs have really grown throughout the years. Underneath the School of Engineering, we have an ABET accredited engineering physics program where students can choose an option in electrical, mechanical, or aerospace engineering. We also have a new civil and sustainability engineering program that is seeking ABET accreditation. We just started that this year, so it'll be a couple of years before we can get ABET accredited. We also have construction management and architecture. We have cybersecurity network management. We have an engineering graphics and design, which is an AutoCAD type program. And then we have the two that we're going to be focusing on with this project, which is electromechanical engineering technology and our manufacturing engineering technology program. So let's look specifically on the electromechanical engineering technology program. I'm going to use my mouse as a pointer here, but these are actually a couple of my students. This is actually a picture taken from the university in our mechatronics class, but these are some of the classes that our students take under the electromechanical engineering technology program. So they'll take electrical systems 1 and 2. They take a fluid power class, motor controls, statics and dynamics, PLCs, industrial instrumentation, mechatronics, and motion controls. Now, one of the things that sets us apart, so a lot of people, you might understand this being in education, but a lot of people don't know what electromechanical engineering technology is. And so basically it's automation engineering technology. And so that's our focus. But I do want to point out one thing that it kind of separates us from most other programs is that students come in, they learn PLCs. And up to this point, we share the curriculum with our manufacturing engineering and electromechanical engineering technology programs. But once we get past PLCs, then we kind of split off. And so these are only for electromechanical students, these 3 classes. And in industrial instrumentation, even though we teach them the basics of instrumentation as far as flow level, pressure and temperature, and some other types of instrumentation, PID loops and things like that, we actually build on our PLC class. So they get deep into analog signals, programming with analog signals, and so on and so forth. Likewise, our mechatronics class, even though we look at automated systems, and this is an example of an automated system that we do in our mechatronics class, we are again building on that PLC class and instrumentation class. So students take really advanced programs at this point. They learn how to program HMIs. They learn how to bring VFDs into PLCs to control motors, which leads into our final class, which is motion controls. And so hopefully that gives you just a really good idea of our program when we talk about the project that we did in electromechanical. Now, some of the barriers that I'm sure you'll be able to identify with if you're listening to this presentation with applied engineering programs is, number one, is we're not theoretical engineering. And so we have to have, because we're not theoretical engineering, which obviously you all know, it does not mean that we don't have theory in our programs, but we have to have high levels of hands-on labs and projects. And so because of that, we need to have real-world hands-on applications, which is from the industry. And because of that high levels of industrial applications, it makes it really difficult because, number one, the industry, the technology in the industry changes so often, so frequently. It's really hard to keep up with. And then on top of that, the trainers for our programs are extremely expensive. You all know this, and if you're a four-year university like we are, we're not privy to like Perkins funds to purchase this. And Murray State, and I don't know if some of you are in this category, but Murray State, and especially in our engineering technology programs, are really in between a community college, which has, let's say, NSF ATE funding, Perkins funding, tends to get a lot more state funding because a lot of times if politicians in the state want to change something rapidly, they'll go through a community college, and a research university that has a lot more NSF type grants available to them for the specific research. So we're in between that, and it makes it pretty difficult sometimes to find funding. And so again, that makes it even harder for us to focus on these high levels of industrial applications. Another issue with these trainers is sometimes they're not representative of industrial equipment. A lot of times they're what I call recipe type of learning. And so you'll get these trainers that have banana plugs, for instance, and if you're looking through the books or whatever, your students plug banana plug into port A, and then that goes into banana plug port C. And again, when they're done, there wasn't a lot of critical thinking involved with that skill set, and so it's more of a recipe type of learning. And I think, and I've seen this, that students have a hard time transferring that knowledge that they get from these some of these trainers because they don't have that recipe in industry to say plug wire into port A or wire into port C. Something everybody's dealing with, especially right now with the coronavirus, is increasing budget cuts. Right, I think we can all attest to that. And so you couple all these expensive trainers and everything else with increasing budget cuts, and we have a problem. And so lastly, I want to focus on this. This is something that I know that I have had trouble in the past. I am really good about focusing on hard skills, the skill set that students need, programming PLCs, things like that. I'm really good about teaching those type of skill sets. When it comes to soft skills, not so much. And so what I've heard from our industry liaison is basically that we have no trouble with the amount of knowledge your students come to us as far as technical knowledge. What we need to see is more students who have communication abilities, can communicate with the team, work with the team. A lot of these soft skills that are really kind of difficult to teach in an applied engineering program, or can be difficult to teach. The good news is, I think that this project that we're doing is that we did hit a lot of these goals. And so this is our project. The need was in our industrial instrumentation class, we needed trainers. Long story short, there was somebody that was a very intelligent person, taught the industrial instrumentation before I did, but he was more of a theoretical professor, had a PhD in electrical engineering, very smart guy. Um, but he did not have the industrial hands-on type trainers that we needed when I took over the class for applied engineering. And so we didn't have trainers for that class. And so we needed at least 3 process control trainers. These process control trainers, and you see some pictures here. This is the Festo, this is the Amatrol. Um, they cost between $30,000 to $75,000 each. And we didn't have, I tried to apply for a couple of grants, we did not get them. And so this made it extremely difficult for us because my department or my university, in the middle of all these budget cuts, was not going to give me $90,000 plus to buy these 3 trainers. So what they did give me was $5,000. And when we kind of made it not a joke, but my chair was able to get me $5,000, and he said, "Well, here's the money. See what you can build with this." And so what I did was I took my students in 312. I had 12 students that semester, um, and I divided them into 3 teams, and I gave each team a budget. I said, "You need to build a process control trainer." And I did give them limitations. I gave them certain scopes, but I was pretty open-minded at the beginning, and then we kind of really reeled this in towards the end of the semester. But I did this at the beginning of the semester. I gave them a budget of $1,667 to build 1 trainer each. Now, this was going on while I was teaching my traditional industrial instrumentation class. So we were still lecturing and we were still doing the labs we could do, but we were very limited in labs because, again, we didn't have the equipment. So I would give students some time during lab time to meet as teams. They met outside of class, and then they were. I told them that they needed to find an industrial system that they could replicate with these trainers. And so these groups got together and they went out. They actually interviewed industrial professionals to learn different processes and different processes that they could replicate. And so they designed the trainers and found parts for each team and remained within their budget. Now, once they did all this, once they put all this information together, they actually presented it, put everything in a PowerPoint, and presented it to the class. And then the class as a whole voted on the best design that they were going to follow for all 3 trainers. And what the students chose was a trainer that replicated a water treatment plant. And so I'll show you pictures of that in the next slide. There we go. Okay, here's a picture of the completed process control trainers. Now this is again what students decided to build. I gave each group a project leader that kind of directed to make sure that they were using the same standards for each group. And as you can see, it's pretty uniform. And so the students made the actual schematics. They did the 3D model of this using CAD software. We ordered the parts as a whole when we decided what to use for this. And the idea is these control trainers, you can see the PLCs here, and I'll go over the individual parts here in a minute, but they have a holding tank, and they pump, whenever they call for it, they pump water from the holding tank. They measure flow, they measure pressure, they measure temperature, and they measure level with these. These all feed back into the PLC, and they fill this tank here into a certain level. Once the tank is full, it is heated. It simulates an injection and mixes the water. It settles for so long, and then it circulates back through the system. And so that's the idea of the process control trainers that they created. Now let's take just a quick glance at the part list, and you'll notice they came in under cost, which is pretty amazing. So we had almost $100 or $300 left over at the end of the project. But some of the things that they did with these trainers it was based on industry, but it might not be the specific equipment used in industry, but it still gave them that same concepts that they would have learned using the same type of equipment. So for an example, we use these Click PLCs from Automation Direct. And if you have been around the industry at all, or not the industry, but education long enough in the automation or electrical engineering or whatever applied engineering programs, you're probably familiar with Click PLCs because they're $69 a piece, and they're very effective. And so they bought the Click PLCs. They had to buy additional input and output cards and the power supplies. So this as a whole, it cost around $350 for the PLCs. They also used the cheaper Seymour HMI panels, and so these actually have HMI panels on them as well. It was the cheaper $150 micro Seymour panels. But again, even though we probably won't use these software that the Automation Direct uses in industry, they still learn to transfer the knowledge that they learned in, we use Allen Bradley mostly, and so they learned to transfer that knowledge from programming Allen Bradleys and Siemens to these Click PLCs, because they had to learn this on their own. I didn't teach them this program. So once they did the equipment, they found out the software was free. That was another reason they chose Click PLCs, and then they downloaded it. One of the issues we have with Level is they had a hard time finding a level sensor that would fit in the budget. And so that was a big deal. And so what they decided to do was use this resistive level sensor here, which if anybody's ever messed with automobiles before, this probably looks familiar because this is a gas tank level sensor, and so a fuel level sensor. And so they bought those off eBay for $15. And so they found a really good deal on this, and they work great. And so they had to learn how to improvise with the budgets that they had and everything else. Now, I included the Festo carts. Normally, I probably wouldn't have bought those Festo carts, but another program had a grant and they had some left over. And so even though they didn't directly buy those, I still put them in the budget like they did, because again, they needed to stay within the budget as far as that goes. So the outcomes were students learned the industrial systems on their own. I didn't have to teach them how a water treatment plant worked. They actually went out there, they contacted industry, they interviewed, they toured, they figured this out on their own. And so that was just a fantastic way for them to learn outside of the classroom, and they were excited to do so. Truthfully, I mean, you always have a couple students that are kind of slackers, but truthfully, a lot of these students got together and they just really enjoyed this project. They enjoyed what they did. They learned to work as a team, and that's a big deal. Especially, that's one of the things that you hear over and over again. That that's very important for industry, is that they have that teamwork. And so in addition to that, they learned extremely valuable project management skills with this project on top of that. So not only did they learn the traditional instrumentation competencies with this class, they also learned all these things in the background. And so communication, they presented to the class. They had to talk as a team. They had to go and network and with industry professionals and interview them. They also had to set goals and keep those goals. We did this in one semester, which was pretty aggressive. I'll have to admit, looking back, it would have been better to have done this over 2 semesters, but we did it. And so that's some of the real world type applications they're going to have to learn in industry. So a lot of times industries sets goals that are not, that does not seem feasible, but you still have to meet those goals. They learned project budget, so they had to stay within the budget. They had to learn things like using cheaper PLCs, figure out ways around the level detection, things like that. They also had to stay within the project scope and also the project timeline. The bottom line is, on top of all these things, they saved the university between $80,000 and $210,000 by building these trainers. And the best part is that they took great ownership, and they really took a lot of pride, had a lot of pride in the finished product. And so this is a picture of my students in that class and the trainers that they finished. And again, I have students to come back and visit me sometime, since this project they're working. Um, they'll come back and ask me about the trainers and what students have done, what students think about it, and stuff like that. And so this is a pride issue for them. And again, it not only taught those skills, but it also gave the students a sense of ownership in our program. Now, here's some pictures of other similar projects that we've done. This isn't the only time that we've done this. It was just, this was a specific project. I didn't have, when I created these, I didn't have specific budgets, but this is a picture of our automation lab. This is the same lab as this, obviously you can tell. But this is where we teach PLCs, we teach mechatronics and part of motion controls in this lab. And as you can see, these are our PLC trainers. We have 8 PLC trainers in our lab, all the way around our walls here, and students made those. And here's a close-up picture. You can see here we have ControlLogix PLCs, IO Flex, inputs and outputs, analog signals coming in. We have HMIs, and we've since replaced these with newer HMIs. We have VFDs, we got motors, all on this, and students built all these trainers. And so, and again, this was a several year project. I didn't have one class build these trainers. We built a little at a time. Last year, students put these IO components on the lights and the buttons on all the trainers. And this last semester, I had students actually upgrade to HMIs. Now, here's something that's interesting. As you know, we've upgraded to the 81 CPUs in our ControlLogix PLCs. And if you're around this at all, if you were to buy those in industry, they're about $11,000. Allen Bradley and Siemens both do a really good job with working with education. Siemens has the Siemens Cooperative with Education, SCE, and you can see here, this picture here, I've got some Siemens PLCs just kind of spread out throughout the lab as well. I bought 18 of these PLCs with the network cards, with the input switches, with the programs for about $5,000 a few years back. These cards that cost $11,000 in industry, Allen Bradley gave me a huge discount on those. And so I basically bought enough for every one of my PLCs in the lab for about the price of one. So if you reach out to your vendors, a lot of times you can find out, ask them if they give the educational discounts. This is a picture of our motor control lab. This was actually, I actually went to Murray State University in the late 90s and I have an electromechanical engineering technology degree. And this was the trainers we used back then, same trainers. And they were banana plug and play type recipe trainers I told you about. Well, we had students strip down the actual trainers. We still use the table. And then we put all these components that they'll find in industry. And so they actually have to physically wire up motors, use motor starters, the real transformers, timers, and so on and so forth. Now, the question is, how can this help your college? Well, there's a few things here. Number one, it gives your college the ability to create more trainers for less money. And that's very important for applied engineering programs. Students get a sense of ownership. They learn valuable soft skills along with their projects. The project can be used as senior design projects. That's another advantage of it. And then the trainers become a valuable recruiting tool for future students. And I want to take just a minute to talk about this. When I have students come in and they're looking at our program, I'll take them through our labs and I'll tell them, you know, students built this trainer, students built these trainers, and I've always got a plan to build a future trainer. And so an example is we had a local industry that donated a bunch of conveyor belts. And we're going to put those in the back of our motor control lab, and students are going to actually put those together for us as part of a future project. And so I'll tell students about that because that really gets them excited. When they understand that they're going to be building things and getting their hands on the equipment while they're in college, it really gets them excited and it becomes a very good recruiting tool. All right, so I am going to finish up. I am right at 25 minutes, which was my time limit here, but I want to thank you all for watching this video. If you have questions, I think I'm going to be here if you would like to ask me any questions, but if not, this is my email below. Please feel free to contact me at any time. I'll be glad to discuss our project and maybe some ways that you can implement it as well. Have a great day.